System Research Group, Institut Teknologi Bandung. Ninik Suhartini has strong educational backgrounds in urban and regional planning from Sydney University and Institut Teknologi Bandung, and diverse experience as an urban planner, researcher, and lecturer in local government and international bodies. He is also an editorial board member for International Journal of Planning and Development. She is also a reviewer at several international journals. Her research focus are urban governance, informal urbanism, and basic urban infrastructure. Now, Bu Ninik Suhartini, the floor is yours.
Thank you, Yovita. Hello, everyone. Good almost afternoon for you from Australia. Have a good day. Good morning, Busri, and all speakers and all students speakers for today. Hopefully you all safe and healthy at your place. Now I will be your moderator for the next session of main presentation and also discussion. Okay, firstly, I like to introduce the rules for today. Actually, it's just like a guideline for us, just to remind you about several rules of this session that we need to see you using your real name, and also we ask you to mute your microphone during the presentation and also discussion if you don't want to speak, and also you can use the chat box, and also maybe you can raise your hand if you have questions or like feedback for your speakers when we will address them at the end of the session. And also please check again in the chat box whether your question replicate others, so we don't have to repeat your questions. And Yovita and her organizer are happy to maybe like put you in the waiting room again if you forget or you breach this rule. Well, that's for the rules. And now we, before we start the session, I like to invite Dr. Heru Purboyo Putro to give us some opening remarks. So firstly, I'd like to introduce you to Dr. Heru Purboyo Hidayat Putro. Dr. Heru Purboyo Hidayat Putro is the head of Regional and City Infrastructure System Research Group of ITB, with educational background from University of Paris and ITB. And Dr. Heru, beside his position as the head of research group, Dr. Heru also holds a very important position in ITB as director of Research Center for Tourism Development. Dr. Heru has been involved in various government projects in infrastructure planning, tourism planning, and urban and regional planning, with research focus on urban and regional planning, infrastructure management, and planning theory. Dr. Heru also a prominent reviewer for some international journals. Since Dr. Heru today has to attend a defense examination for a PhD student, which is done offline, so Dr. Heru has sent us his recording for opening remarks. Okay, Yovita, can you please come to the opening remarks, please?
Could you see the screen?
Going there. Yeah.
Good morning, ladies and gentlemen. I would like to thank to you all for coming and participating in today's seminar. We from ITB's Research Cluster for Urban and Regional Infrastructure System as the host for this seminar with the topic of Sustainable Urban Water Management, which is a joint seminar between ITB's and the Deakin University. First of all, I want to thank to Bu Ninik PhD and her colleague who have prepared this seminar and also student presentation of the two universities. Also, I am very grateful to Bu Sri Mariati, PhD, who is apart from being the Dean of the School of Architecture, Planning and Policy Development, but she also will give her presentation on urban water today. Also, I'm very grateful to Professor Baskaran, Professor Layet Chua, and Professor Bu Riza from the School of Engineering, Deakin University, and also Ibu Kusuma Rukmi, PhD, from Development Planning Agency of Bekasi Regencies, West Java Province, who will share their experiences in urban water management issues and also their thought on the need to connect with the perspective of sustainable development goals. Distinguished audience, let me share an opinion about the urban water management, which is part of the built environment and linked to the sustainable development goals. I will use the study from Maniam et al., that article published in the Water Journal in this year. According to them, the water situation in Southeast Asia has changed from one of relative abundance to one of relative scarcity. Conventional water management that being put under the strategies around the provision of adequate water supply to users has limited sustainability. Though nations in this region has adopted the United Nations Sustainable Development Plan into their water management framework, successful outcomes are limited. Results from their review show that a large proportion of Southeast Asian population are not part of a water sustainable society, and this presents a major hurdle for the countries to meet United Nations Sustainable Development Goals by 2030. Therefore, active cognitive engagement through the creation of a water literate environment is critical to achieve long water sustainability in Southeast Asia countries. Water literacy, in their perspective, consists of 6 pillars of water. These are about water sources, water management, water knowledge, water attitude, water behavior, and water-related issues such as health, social economy, water supply, and ecosystem. Another opinion coming from Powder et al., also from Water Journal published in this year. According to them, water scarcity, together with the projected impact of water stress worldwide, has led to a rapid increase in research on measuring water security. Water security has been conceptualized under different perspectives, including various aspects and dimensions, while supply-demand and governance narrative dominated several popular water security frameworks. Their study focused on public health as an important aspect of water security. Their study shows that water quantity is more of a common issue for both developed and developing countries, and water quality and mismanagement of water supply related infrastructure is the main concern for developing nations. It is also necessary to consider how people treat and consume the water available to them. They give suggestions to develop comprehensive ways to refine the public health indicator at a ground level to measure the significant burden that water insecurity places on human health. And today, we are holding a seminar in Indonesia, more precisely in the city of Bandung in West Java province, which is a part of the tropical region that has relatively high rainfall. In West Java province, there are many rivers with water flowing throughout the year. There are also many springs. Actually, it is a bit ironic that in such area, there are a water scarcity during the dry season, but then sometimes there are some flood disaster. It is known that there was an idea about harvesting rainwater and also some ideas of how to make water not immediately flow into the sea, but rather be held and absorbed in the lands that are planned and provided. It is also known that the water is one of the common pool resources whose decision to use it should not be made unilaterally, but must involve as many stakeholders as possible. About all, we will hear in more detail from our speakers today. Once again, thank you all for joining this seminar.
Okay, thank you, Pak Heru, for very insightful opening remarks. So before we go to the presentation session, we will commence this morning with a photo session, and Yovita will help us to cheer up for the session. Yovita.
Everyone, please turn on your camera, please. I'll take the photo from the first slide. 3, 2, 1. Next slide. 3, 2, 1. The last slide. 3, 2, 1. Thank you.
Okay, thank you, Yovita. Thank you, Professor. It's very Indonesian that we make sure everyone get captured in the photo session. Now we come to the main session of today, which is presentation session. Today we are very lucky to have high-level professors, high-level academics from Deakin universities and also from Institute Teknologi Bandung. We have here Professor Baskaran and also Professor Lloyd Chua, Professor Bu Beza, Professor Dr. Sri Mariati, and also Dr. Kusuma Rukmi. Okay, firstly, I'd like to introduce you to the first speaker, Professor Baskaran, or Dr. Rukmi suggests me to call you Bas if you don't mind. So Professor Baskaran is the Pro Vice Chancellor for International Research Partnership of Deakin University. Professor Baskaran, accomplished strategic leader with high-level knowledge and experience in strategic planning, building and maintaining professional relationship and cross-cultural communication. Bas, also the head of foundation in civil engineering in the School of Engineering, and also the Associate Dean for International and Partnership for the Faculty of Science, Engineering and Built Environment in 2010. Bas also actively involved in development of several industry, including university collaboration in India, including Ford, University Alliance, Cyber Security Network, Australia-India Water Center, and also Sustainable Future Infrastructure Development. Professor Baskaran also has extensive knowledge and understanding for the Australian water industry and has successfully completed several industry-funded research projects over the past 25 years. Now we welcome Professor Baskaran to deliver his lecture. Bas, the time is yours.
Thank you very much. Thank you for your introduction. I'll see whether I can share my slide. Hopefully it works. Okay, good morning for my colleagues in Indonesia, and also good afternoon in Australia. I'm going to talk about the integrated urban water management in Victoria and particularly in Melbourne. And I'll say one thing first, that Australia or the Victoria get an annual rainfall about 500 millimeter or 550 millimeter a year, compared to the rainfall in Bandung is about 3,000 millimeter a year. So it's a completely a different scenario. But we went through 10 years of drought for quite some time, and then the integrated water management is developed in that period. So where we go from here and how we develop the integrated water management, and then some of the issues what we face, I'll cover in this talk. The integrated water management is a collaborative approach to planning that brings all the organization involved in various aspects of water cycle, including water waste management, wastewater management, all native and potable water supply, stormwater management, and water treatment. It considers the environment, social, and economic benefits together, and it provides the potential to provide greater value for our communities. For quite some time, the water cycle management is fragmented in various countries and states as well. So the practice is you take the water, treat it, and provide for drinking and other purposes. And then you collect the wastewater, take it as far as possible, and then discharge into the environment and treat it. And then the stormwater is considered as a nuisance of flooding. The local government here, the view of stormwater is, if I can get rid of the stormwater as quickly as possible, it doesn't cause the flooding, then it's fine. But the integrated water management is trying to connect all these as a possible interlink between all these things to provide a sustainable water management to the urban area. So there needs to be a paradigm shift, how we look at water management and how do we look at integrate these systems and make it sustainable. So the water, if you look at the wastewater, 99% of the wastewater is water. Stormwater is again, there's pollutants in there, but there's a majority of the water can be reused. This is all available in the urban environment. And we treat the water for drinking quality purposes, but then use majority of the water for non-drinking activities, even within the household. So we need to look at how do we come up with a water system which suit the quality for the purpose of using it. And then more and more, we are talking about energy. So how do we optimize the energy usage? The biggest energy in water is moving the water from one place to the other place. And also what type of materials you use and how do you recover the water for various purposes as well. Of course, it has to be safe and resilient for external impacts. We have to make sure the water quality is fit for purpose for the particular usage, and it has to provide triple bottom line, social, economical, and financial benefits as well. And then it has to be much more comprehensive at a local level, national level, and also at the watershed level as well. So the impact of climate change is as a significant issues into the water management side of it. Here, sometimes we have drought, sometimes we got flooding, sometimes we have the quality issues. And how do we find the new sources of water? How do we manage and interconnect our existing systems? And then one of the biggest issues in Melbourne is the old infrastructure. Most of the pipeline are buried underground and they are aging as well. And then the population is growing. We don't have enough water. How we create potentially increase 25% Australian population with less water availability. And in the meantime, we see a lot of impact of climate variation, the droughts and the bushfires in Australia, but also the flooding causes as well. I'll leave two of my colleagues to talk about some of the stormwater management side of it. So the integrated water management is to try to bring everybody involved in managing the water system into a much more collaborative approach to talk to each other, come up with a plan, come up with a solution which meets the expectation of the community, as well as the environmental aspect as well. So the two clear advantage of integrated water management is collaborative solution, as well as it gives a better value for community investment. So how do we engage the community? How do you engage the stakeholders? How do we engage the people who are responsible for managing different aspects of the water cycle? It's always a challenge. And also to make sure individual needs and individual responsibilities are met as well. So some of the outcome of having an integrated water management system is for the community. We are looking at a safe, secure, and an affordable supply in an uncertain future, where the future is and how the availability of water, but we need to give them some sort of certainty, not only for the community, but also for the industry to develop an effective and affordable way to manage the wastewater systems. How do we recover the water from the wastewater and using for not potable uses? And in new development in Australia, most of the new development has a third pipe system, provide recycled water for garden and other requirement. How do we manage the stormwater and consider stormwater as a resource rather than a nuisance? How do we capture the stormwater because it's available pretty much in the urban area? How do we store it? How do we retain it? How do we ensure the water quality is right for the purpose of the use as well? And then by retaining the stormwater, it provides a healthy and value urban landscape, bring some natural habitats back into the urban environment. How do we provide a cooler and a greener cities is an important aspect as well. And then the community value is reflected in the place-based solution planning, where you look at a particular area, how do we plan, how do we bring everybody together in that area to look at the entire integrated water management in that space. So there are a lot of opportunities that can be leveraged by adopting an integrated water management, where you minimize the flooding, adapt to the climate change variability, minimize the energy usage, and so forth as well. And also potentially look at irrigation, agriculture, landscape in that urban environment as well. So in Victoria, if you look at people or the organization which involved in urban water management, it's very significantly. The Victorian government or the state government is similar to the provincial government in West Java, responsible for the legislation and policy and regulatory aspect of it. We got an environmental protection authority. We mainly look at the environmental regulation and best management practice guidelines, mainly to protect the environment from various aspects. The Essential Services Commission, which control and monitor the pricing aspect of it. In Victoria, in Australia, we all pay for water. We all pay for the water supply. We all pay for the wastewater collection system and so forth as well. So the Essential Services Commission is pretty much a economic regulatory controller. Water Corporation is the organization provide water supply, collect wastewater, treat it, and discharge it. And in certain part of the Melbourne, the waterways and drainage system are managed by the water corporations as well. The catchment management authorities mainly look at the waterways and the health, floodplain. Local government is very much involved in the stormwater management, parks, gardens, and so forth. And then individual owners and the residents to maintain the facilities in their property. And then the planning authority, which looks at the urban growth future and the planning aspect of it. And then the developers, where they develop all these urban development schemes need to meet certain requirements. So in a successful integrated urban management, we've got to make sure the relevant people from various authorities are part of the discussion, part of the development of the planning process as well. So in that context, it is important to define the clear accountabilities and also to identify the shared values. Particularly in an urban area, we look at the water corporations and the local government, the catchment management authorities involved in a day-to-day planning and implementation of any integrated water management plan as well. So we have to collaborate, they have to share information, and also to make sure whatever the projects have been implemented, it's an important aspect as well. Just to give you a snapshot of it, this is the Melbourne water supply system. Melbourne is a base pretty much, and one of the aspects is on the edge of the Fort Phillip Bay, which is the landlocked bay. And then the water supply catchment come from what we call it as a protected catchment area. We got about 10 reservoirs. Each of these reservoirs are interconnected. So we can transfer water from one reservoir to the other reservoir and manage the system. So in theory, in Melbourne can supply water for about 7 to 8 years without a single drop of rain, because we have that storage capacity. But on top of that, we have a new desalination plant built up here, called Wondaki, and it's connected to one of the reservoirs here as well. And then the whole system is also connected to the northern part and also to the western part as well. So we have a very much integrated, interconnected water supply system. In the wastewater collection system, we have a major treatment system, a land-based treatment system in western part of Melbourne, and we have a well-advanced treatment system in the eastern part. Because this is a landlocked bay, the treated wastewater from here has to be discharged all the way to the bay. But then during the drought time, that pipeline becomes an ideal opportunity to supply recycled water for this entire area for agriculture purposes. And then we've got quite a lot of pumping stations to pump wastewater from one place to the other place to get to the treatment system as well. In the drainage side of it, we have a very sophisticated drainage system across Melbourne. The black dots are drainage retardation basin to retain the water, and then the blue dots are several wetlands. Even though we maintain and manage these retardation basins and the wetland system, when you look at the quality of the water in the various waterways, is significantly different. You will see up in the hills where our catchment area, the quality of the water is really good. When you come to the urban area, the quality of the water in the streams and the rivers are pretty bad. They are mainly caused by stormwater runoff rather than any discharge from on-site treatment system or a wastewater system. So in order to manage that, we have to bring the stormwater management into an integrated water management plan to protect the environment, but also improve the quality of the water systems as well. So part of the planning process, what we established in Victoria is the integrated water management forums. These are collaborative groups of leaders from various organizations who are interested in water cycle management. We bring them together. These forums will, so across Victoria, we got several forums in each of these regions. And then in the metropolitan, we got about 5 forums bringing different parts of metropolitan area. These forums will consider the water cycle with an urban focus and extend some of the pre-urban boundaries as well. We look at some of the natural and constructed assets. How do we manage that? And also these are influenced by some of the landscape and the land development aspect as well. So these forums are very much facilitated to collaborate water management planning across organizations and sectors, come up with a shared vision for the water management for that localized area, identifying some of the priority projects, and then to look at some of the projects at an area scale, whether it's a stormwater management, whether it's a recycled water usage, and the urban landscape aspect, and then to identify some of the barriers to delivery, and then make sure the investment in there, and also to ensure these are delivered to the community as well. So part of the planning process, these integrated water management, first you've got to establish these forums, and then you work out with various working groups to develop these individual plans for the prioritized projects. And then we got to make sure all the organizations involved in the water cycle management incorporate these plans within their own planning system. And then we got to ensure these projects are delivered and implemented as well.
But sorry to interrupt, but I believe we have only 1 or 2 minutes left.
Yep, it's almost done. And then part of the plan development process is a clear definition of the accountability, and also to define the shared outcome, and also looking at the service options in order to cost benefit analysis and so forth. And then how do we fund them? How do we make sure the cost and the risk is shared across various organizations, and then the implementation part. This gives you an overall aspects of water management, water planning in an urban environment. Thank you very much.
Excellent, fantastic, just right on time. Thank you, Professor Bhaskaran, for opening the day with your comprehensive and very insightful lecture. Here you highlighting the paradigm shift that have occurring now in water management system, and also different relationship between stakeholders in managing water management, and also the need that we have, the need to see the relationship between water, wastewater, and also other aspect of natural resources in managing water. Thanks again, and we'll see you in the discussion session at the end of this session. Now I invite the second speaker. Sorry, it's not second speaker, but the next speaker. That is, apologize for the Indonesian style. Yeah, our next speaker is the Associate Professor Lloyd Chua. So Lloyd is the Associate Head of School International of Civil Engineering of the School of Engineering of Deakin University. Lloyd teaches subjects related to hydraulics, hydrology, and numerical and water quality modeling. And Lloyd obtained research position in many institutions, including adjunct professor at University Tenaga Malaysia, and also a research affiliate at the School of Engineering at MIT. And Lloyd also is the associate head of School International, where Lloyd is in charge of international activities related to the school, and the recipient of 2005 Hilgard Hydraulic Prize, or ASCE. And Lloyd has won Best Papers award in several years back. Lloyd also very well known as a reviewer for numerous journals, and he has published more than 100 papers in refer journals and also conference papers, and has research interest in water quality monitoring, modeling and management, and also flood modeling. So Lloyd, now I invite you to give us about 15 minutes lecture. The screen is yours.
Thank you very much, Nick. Sharing my presentation. Okay, can you see my presentation?
Yes, clear.
Okay, good. Thank you very much. Thank you for the introduction again, Nick, and yeah, good morning, I guess. Selamat pagi to all our colleagues and students in Bandung, and good morning to colleagues in Australia. So Bas has given quite a detailed account on integrated water management, but more from a regulatory kind of perspective, looking at governance and those kind of issues. What I want to do is really look at integrated water management, but coming from the other end of the spectrum. And that's because I'm an engineer, and I look at, for example, if you have management measures in place. I asked the questions, for example, how are they performing? Are they performing as intended? And we also look at the questions, for example, do we understand these systems well enough? And if we do understand these systems, are we able to make accurate predictions? Are we able to model such systems? So this is where, this is my background. And in today's talk, I want to approach this whole topic on sustainable urban water management, looking at those issues. What I will do in my presentations, I will talk through 3 examples. I will showcase 3 examples of work that I have been working on together with my students, just to highlight some of the issues that we are facing, and hopefully to be able to answer those questions that I posed. The first example is taken from Geelong. So this is where we are located. Geelong, in the past, since 2014, we have had 3 large storm events, relatively large, shall I say? For us, it's large. 3 relatively large events since 2014. And when I say large, they are supposed to have exceeded 1 in 50 years. So since 2014, that means in the period of about 7 or 8 years, we have had 3 events that have exceeded 1 in 50 year return period. So this is an exception. And if you look at the rainfall, of course, they are small in terms of by Indonesian standards. Let me just get my pointer up. So if you look at in terms of the total rainfall, they are small by Indonesian standards, but large if you have, if you live in a city, where you get about 0.5 meter of rain a year, for example. So, and what my student has been doing is to look at how well we are able to model these floods and how well we are able to predict these floods. So I'm not talking about real-time modeling. I'm just talking about simple modeling, given the storm event that has occurred. Make some model predictions and look at how well those predictions compare to what we've seen in the ground. And if you look at some of the, for example, the 2016 event, we have had quite a number of, a fair bit of a damage and also some damage to property. So this is the catchment that we're looking at. This is Melbourne, this is Geelong, and this is a blow-up of Geelong. And the area that we're interested in is really this portion here, which encompasses part of the Geelong CBD. So the catchment that we are interested in is here, and the yellow color shows the reticulation system. So again, this is the area that we are modeling, and this is the model that we are dealing with. So this is the pipe systems that we have put into the model. And basically what we try to do in the model is that we model everything that's up to a building scale. Anything smaller than that, we neglect. So we don't look at lampposts, we don't look at things like curbs and all that. And we apply 2D surface flooding, 2D flooding to the surface, and a 1D flow to the drainage system. And this is a result of that model. And you can, if you just focus your attention to the top left-hand picture, this is a retarding basin, which is a Johnston Park, which serves as a retarding basin, basically to store the excess storm water or flood before final discharge. And you can see quite a bit is captured here, and also this area, which is a road that goes under a railway line. What does the model tell us? Well, if you look at the hydraulic grade line of the model, it tells us that a couple of the nodes will be surcharged, and this is the Johnston Park area. And if you look at Johnston Park, for example, you can see a permanent inundation after the cessation of the flood. During the flood event, you can see boils of water, on the surface, and this is because you have surcharging from the manholes, and so you can see quite disturbing pictures in a sense, because you're basically getting head of water that's coming up through the manholes because of the surcharging. On Gordon Avenue, it's the same story. You have the road that's going under the railway line, and you can see again inundation. And this is a picture of that road with the railway line above it. And this is the model prediction. So how well are we doing? Actual flood inundation level from here, you can see it's about 1.5 meters. Well, the model is telling us 1.2 meters. And this is pretty good, given that we have not really done much calibration with the model. So with more calibration and with better tweaking of parameters, this number would be closer to this. The next example I want to talk about is on a natural wetland system, and this is in Phnom Penh. So Phnom Penh is the capital city of Cambodia. City of Phnom Penh is here. This is the Mekong River. This is the Tonle Sap. This goes up north into Siem Reap, and this is the Basak. So the Phnom Penh city of Phnom Penh doesn't have a treatment system, wastewater treatment system. So the wastewater, they operate a combined sewer system where you combine the wastewater and storm discharge, which goes into a natural wetland system. If you look at the picture on the right, air photos taken in 2003, 2017, and you can see in these areas here, for example, infilling of the wetland system. So the question is, if you start to infill your wetland systems, what does that do to storage capacity? How does that impact floods in the city? And how does that impact our water quality? Because don't forget, the wetland system is basically a treatment system which treats the domestic sewage before discharge into the Basak. And you can see in this picture, here we have landfills that have been in these areas here. These are all landfill obviously for development. You can see houses, for example, in the background that have been constructed. This is a newspaper report taken in 2014, and you can see floods that have been being reported and experienced by residents in the city. A picture of the drainage system. So the city of Phnom Penh, I guess, similar to what you would have in Bandung and probably Jakarta as well. You have a surface drainage system designed for 1 in 50, 1 in 100 year systems. And you can see this is a combined system. So you can see here, it would be combined of storm runoff and also domestic sewage. And of course, quite a bit of solid waste as well. If you go downstream into the wetland, you have an agriculture area, basically peri-urban agriculture, where here they are growing water spinach. I think in Indonesia, you call it kangkong. Southeast Asia, we call it kangkong. But basically here you can see peri-urban agriculture. And the question then is, not only do you reduce the capacity, but you also take away, I think, a bit of the livelihood of some of the local community. The question then is, how do we assess this system? So here, I think modeling comes into play. The question, the answer is, the question is, can we, assess or can we quantify the effects? The answer, of course, is yes, and we can do it with a model. So this is the discretization of the system. The top part here basically is the urban area, and the bottom two zones here are the wetland areas. So we can divide the areas into two parts. One is the urban area, and the bottom two into wetland areas. So this is basically where the integrated system is important, because you need to integrate both the downstream and the upstream. So coming back to the question, how well are we able to make predictions? In this case, I've shown some results of the water quality. Well, I would say we're able to make quite good predictions. And you can see here, for example, we're now making predictions on the pathogens of E. coli, and also on the nutrients and some chemical contaminants. So before I leave this slide, I just want to say that the main bulk of this book was done by a colleague of mine who used to be in Singapore, but now is in Thailand. The question of wetland, natural wetland treatment systems such as these that are currently being infilled and currently where capacity being reduced, this is, I don't think it's a problem that's only limited to Phnom Penh, but I'm sure in other parts of the world, we're facing similar issues as well. The last example I want to talk about is this is a bioretention basin, or what is termed as a rain garden elsewhere. Again, work done by one of my students. A bioretention basin, basically, if you can look at the picture on the right, basically stores excess surface runoff. And normally the design would be stored for a period of 3 days or 72 hours before final discharge. During the storage, what happens then is that you have infiltration of the stored water into the subsurface, and therefore it goes through a sort of a natural treatment. So that's the idea. And if you can look at this picture here, the subsurface basically, so this is an engineered system. So you layer the soil starting from fine gravel at the bottom, then you have a rock layer consisting of wood chips. The wood chips basically act as an organic carbon source. Then you have a fine sand material, which basically separates the infiltration, the saturated, the sandy loam layer from the drainage layer. And you can see during construction at various stages of construction, here there's a lining that prevents the exchange between the groundwater with the bioretention basin. You can see the pipes here. These are for the drainage. And you can see now the placement of the fine gravel layer being in operation. But this picture here shows a nice kind of section through the entire basin. You can see the bottom part here, a thin layer of fine gravel followed by rock layer, then the intermediate layer followed by the filtration layer. And this is a picture of the bioretention basin after construction. Now this shows you a nice schematic of how such a system works. Basically, you have stormwater coming in, fills up to the design level. Whatever is excess of the design basically then gets exits through a culvert, some sort of a high discharge. So normally we would design such systems, let's say for 1 in a 3-month system return period. Anything above that goes out undischarged. And the portion that's infiltrated basically goes into, passes through the filter middle layer and then exits through the system. And you can see the water here is basically treated, is clean. Once it's come out from the system, it's clean. Now, this is a video showing you how such a system works in real life, in practice. This is quite a big storm event, so peak intensity of nearly 100 millimeters per hour, average intensity is about half of that. And you can see the storm water that's coming in is filled with a lot of course, debris, and of course, carrying with it other contaminants. And it basically flows into the system. Let me go to the next picture. Yeah, this is a picture showing after the storm event where you have the water that's stored within the basin. And as you can see, the stored water stays in the basin for a certain period of time. And during this period of time, the infiltration occurs before final discharge. I just want to maybe end off by talking a bit about the work that was done by my student. So basically what my student did was to instrument the system. So we had water level sensors in the basin floor. Then we also monitored the level and the discharge in the outlet pipe. We had the rain gauge on site, and we had samplers on site as well. So we were basically able to monitor both the hydrology and the water quality of the system looking at. And we could then answer questions, for example, how much removal had taken place, and also look at the hydrology of the system. And I just want to maybe finish off with very briefly to talk about the results. So these systems are basically designed to remove nutrients and of course suspended solids. In terms of nutrients, the removal of nitrogen, for example, follows a biological process. And to be able to do that, then we need to be able to model both the, for complete removal, we need to model both the nitrification and the denitrification stage. So for nitrification is where you have conversion from ammonia all the way down to nitrate and nitrite. And then If you remember, if you recall, we had the bottom two layers where you had a layer of wood chips and the drainage layer. Now that area, those two layers are kept permanently inundated, so you have a saturated zone, and that brings about anaerobic conditions. And once you have anaerobic conditions, then the process of denitrification can take place. So with these two processes, then we are able to convert all the ammonia nitrogen that is stored in the inflow and treat it and remove all the nitrogen and basically having a nitrogen gas as the end product. So basically, such systems are now being implemented in many parts of the world. And initially, many systems failed because we lack the denitrification stage. So we were just converting nitrogen from one form to another without actually removing it from the system. But now with the denitrification layer, that is now possible. And I think we've learned quite a bit how these systems work in the past years. And this is now working quite well in many places. So with that, I think I've taken up my 15 minutes. So I'll stop my presentation here. Thank you very much, Ninik.
Okay, thank you, Lloyd. Thank you for keeping the time. Very interesting presentation. Here you give us very rich examples in how we using different technology on different contexts and also different issue of water management. Thanks again, Lloyd. We will come back to you at the discussion session. Now I invite the next speaker, also from Deakin University. Yeah. The next speaker is Associate Professor Bu Biza. Sorry, do I mispronounce your name?
That's okay. Bo.
Okay. Oh, Bao. Bao. Is it?
Thank you.
Okay, Bao is, yeah. Thank you, Bao. So Bao is the Deputy Associate Dean of Teaching and Learning in the Faculty of Science, Engineering and Built Environment of Deakin University. Bao obtained his undergraduate in landscape architecture and master from urban and regional planning, and he obtained his PhD also from architecture and design. Bao has registered professionally as a landscape architect with the Australian Institute of Landscape Architecture, where Bao is the chair of National Education Committee. Bao achieved a very excellent research impact. About 20% of his publications have been ranked in the top 25 most cited publications in the world. With 50% of his publications have been published in the top 25 journals. This is so fantastic. And almost 100% of his publications have been cited, and Bao research focus has been cited by researchers in about 45 countries. Now we welcome Professor Bao Biza to bring your presentation. Bao?
Thank you very much. And it's an honor to be here. Good morning and good afternoon to everyone. I'm going to talk to you about integrated water management more from the perspective of a designer. My qualifications, my background is very different to my colleagues, where we had Baz talking about the high level regulatory kind of groups, organizations. We had Lloyd talking about modeling and the direct application of it. So we're talking about a spectrum there, and I'm going to be somewhere in the middle talking about design. Now, let me just show my screen. Now, can you see the presentation?
Yes, clear.
Okay, great. I've got 3 screens here, so if the presentation goes cuckoo, let me know and I'll try to bring it back online for everyone.
No problem. That's my job.
Okay, thank you. Okay, so I'm going to talk to you more about what I like to term water sensitive urban design. And so this is really thinking about using rain water or storm water in new and existing urban developments itself. And I'm going to primarily use Melbourne as the mechanism to show you that, or to illustrate that. But I need to take a step back because I like to use the word water sensitive urban design when I'm talking about integrated water management, but around the world, it's used differently. So here in Australia, we have water sensitive urban design. That's the term, and it's the integration of urban planning with the management, protection, and conservation of the urban water cycle. In New Zealand, they refer to it as low impact urban development and design, LIUDD. And they apply concepts of ecological carrying capacity to reduce the impacts on the environment. In the UK, they use what's called SUDS, or Sustainable Urban Drainage Systems. And that's realizing open air drainage systems in new and existing developments to slowly move water through a system. And then in the USA and Canada, they refer to it as LID, or low impact development. And that's implementing natural and or constructed means that encourage water to percolate into the ground. So that's roughly water sensitive urban design, integrated water management, kind of how it's termed or referred to around the globe. In Australia, when I apply water sensitive urban design, I have to say that Australia and its residential population is primarily urban. I'll show you an image in a moment, but a lot of our urban developments look like the center bit here. So this is Melbourne, and keep this picture in mind because I'm going to talk about the outskirts of Melbourne. So the stuff, the development way in the distance there. So here in Oz, we have lovely beaches, a strong indigenous population, and we're very, very urban. We have 18 major cities in Australia. That's 100,000 or more in population, and that's gone up a little bit because this is an old reference. But if you can see, most of our urban development is along the edges of the country itself. There's a lot of emptiness in the center itself. So all our urban development, or most of our urban development, is along the sides of the country. When I look at Melbourne, and this is where I'm going to start talking about water sensitive urban design, and many of these images are pre-COVID. We have bays, a lovely bay that Lloyd showed you, Port Phillip. But in the state of Victoria, we also have mountains and snow at the peaks during some times of the year. And again, very urban in its setting. And this urban dimension is very important because that's what we'll be dealing with the city. All right, so here in Victoria, when we start talking about water sensitive urban design, planning for it, urban development and its visioning occurs at 3 different levels. So remember when I mentioned that photograph of Melbourne and look beyond and look at the development off in the distance? Well, at the big picture level of development in Melbourne, we look at growth corridors, or growth area framework plans, which accommodate about 100,000 to 400,000 people. So these are large urban areas that we're planning for. When we start to apply water sensitive urban design at that level, this gets into the realm of what Baz was talking about, of state or national policy, concepts of urban sustainability, such as city as catchment or water cycle management. So these are big picture things that are applied. And this is a picture from an image from the City of Melbourne, a website itself, that talks about water sensitive urban design at the regional scale. And it starts to apply stormwater management or water sensitive urban design in the planning regulation, the regulatory framework itself, where there's definitions, there are objectives, and they start to slowly go from big picture and go down to a smaller application. But this is where the legislation, where the developers take note of water-sensitive urban design, and it's all accessible on the web. And the community is very knowledgeable in this as well. We then go to the next level down. So there's 3 levels. That was the big picture growth area. Now we're at the precinct level, and this accommodates about 7,000 to 30,000 people in the urban area itself. So this area through here is at precinct level. And at the precinct level, when we start to apply water-sensitive urban design measures, this is where we go from concepts, regulation, as Bas was mentioning, or mentioning in his talk, to pen to paper, where we might start to come up with concepts, schematic designs, ideas. And we work off a concept of the building itself, how rain may fall into that, and then flow through the system, how we may capture it. It goes into our open spaces and then flows out into either the bay, the ponds, the streams, rivers that run throughout the city. So that's the concept I mentioned, a pen to paper. Then we start to apply it at the precinct structure plan level, where we start to plan, map out where things like underwater storage tanks might be, how water may move through a system, how it may be captured in pipes directed to open spaces. And then we come up with plans exactly, well, detailing, this is an artist's impression of what an area in this precinct structure plan could look like. So this is a stream running through here, and it's designed to illustrate, or this is illustrating, if you want to say, a nice flow of water moving slowly, and you can see that it's there's a bank here, so that as the water increases, it's managed itself. So I guess again, illustrations, pen to paper, we're now starting to design the use of water-sensitive urban design in a new development itself. Now we're at the planning permit, so a small scale of urban development itself. And this parcel of land right in the center affects about 500 to 5,000 people itself. And so this is the subdivision or permit scale that lays out the homes, the stores, the open spaces, the roadways itself. So this is the detailed application. And at this level, we start to apply the water sensitive urban design measures. So we go from pen and paper to now building it at the roadway level. So starting from the right here, if you notice, this road slopes into this swale. There's no edges, and the water hits the verge here, slowly moves through the water. It's clean, as Lloyd was talking about, with the removing of particulate matter, etc. And it goes into the center of the swale, and it slopes down, and you can see off in the distance a catch basin. Here within the water, the stormwater is taken away to a basin of somewhere, or however it's designed. I don't know what they're doing here. Those are actual sandbags. I think the designer didn't quite get that right. They're trying to slow the water flow. So a point to illustrate, the designers don't always get it right. We've been doing this for years. Sometimes we make mistakes. So when that catch basin collects the water and it takes it to a rain garden. So Lloyd illustrated a large rain garden. This one is at the neighborhood level or scale. But again, this is an inlet back here where the water comes in and it fills up. And it's a very nice system that's created. But if the water starts to flood, if you want to say, here's an outlet. So again, Lloyd illustrated this, where the water comes in. Once it gets to a certain point, it then goes back out and taken away. This is at the very domestic. So we're going from the neighborhood, the streetscape, a park, if you want to say, to a house itself. And this is my garden in the back of my house. So the rainwater falls on the roof. It comes down the pipes into, this is about a 5,000 liter rainwater tank. And I use it to water my veggies here. And there's the little pump and the power that allows this to occur. Importantly, though, this isn't drinkable. This isn't potable water. It's just to be used in the garden. And there's a lot of, I guess, if you look at the paving here, it allows the water also to percolate down slowly into the ground. So we're recharging the system. There's not a lot of hardscape surfaces there. So big picture from the street, a park, down to the domestic application of it itself. What I was talking about those different systems from the street, a park, to the domestic application are what we might refer to as soft and hard water-sensitive urban design measures, where an education program, for example, like what we have here today, might be considered a soft measure. But some of the retention basins, retarding basins, the streams and riparian rehabilitation corridors, or swales, like I showed you in the street, and vegetation buffer strips, that might be considered a soft. A retarding basin might be considered a soft measure or a hard measure. The point is that there's different terms, there's different ways to consider these measures themselves as soft, something as a pond allowing water to percolate into the ground, or a hard measure, a channeled, concreted type of surface that allows water to go through quite rapidly through a system. So soft and hard measures. Now, there's a great book, and the material that I presented to you today is from this book, Approaches to Water-Sensitive Urban Design. Now, I show it to everyone as a tool, as a device, if you like, to learn more about water-sensitive urban design. And it covers a range of topics, all related to water-sensitive urban design. The material, again, that I presented is in this book. I don't get any royalties, nothing like that. So I'm not advertising it. I'm just saying, as a resource for our students and colleagues, that is there for you to use. So I just want to thank you. And just to reiterate, so what I was talking about, those three different levels of planning and design, help kind of to bookend, if you want to say, Baz's discussion about regulation policy, the group kind of dynamic, and then Lloyd's itself, the modeling and direct application. So this implementation and using water in new and existing urban developments. So thank you.
Thank you, Bao. A fantastic presentation. It's very interesting that your presentation actually glued together the three presentation into one, that we need to consider different levels of intervention, if I may say, and also different contexts in the different contexts of water issue. Thanks again, Bo, and we get back to you at the end of the session. Now we go to another side of the world, which is Indonesia. Now we will hear some more example and some more insightful presentations from our side. Now we like to welcome Dr. Sri Mariati. Dr. Sri Mariati is the Dean of the School of Architecture, Planning and Policy Development of ITB. Dr. Sri Mariati has a very strong background in urban and regional planning and infrastructure planning, as well as environmental engineering. Dr. Sri is certified planner from Indonesian Association of Urban and Regional Planners. And Dr. Sri teaches some subjects related to infrastructure planning and analysis methods in planning. Dr. Sri Mariati also involved in various government works related to infrastructure planning and management. And Dr. Sri focus is on urban and regional infrastructure planning and management, especially water infrastructure and other basic infrastructure, as well as urban and regional planning in general. Dr. Sri Mariati also a reviewer for some international journals, and Dr. Sri is a key member of the Regional and City Infrastructure System Research Group. So now we welcome Dr. Sri Mariati to give us the presentation. Dr. Sri, the screen is yours.
Yeah, thank you, Bu Nini. Yes, okay. Yes. Okay. Today I have the topic to be discussed. That is urban water management in Indonesia, planning and implementation. So here I also will talk about the policy and also the plan that exists in Indonesia, and how is the implementation of the plan in Indonesia. So before come to the main discussion, I would like to introduce the administrative division in Indonesia. Maybe some of you do not know about this. So we have several level of administrative division, starting from the national level of government, and then province, and then city and regency, district and sub-district. And here we can see the number of province in Indonesia, as well of city and regency, district and sub-district. Regarding the number of population in 2021, Indonesia has 272 million people. And then related to urban population, here we can see that the number of urban population or population that live in urban area always increase by year by year. And then in 2045, it is predicted that around 72.9% of population in Indonesia will live in urban area. And here the condition today, it's around 56.7% of Indonesian population living in urban area. So almost now it's almost more than half of Indonesian population live in urban area. So now before we come to the discussion on urban water management, I would like to also introduce the status of urbanization in Indonesia. This is the number of urban population based on province in Indonesia, and we can see here that the concentration of urban population is actually in Java Island, as we can see here in the yes, here in the red box, this is the province in Java Island. But also we can find that in some province outside Java Island, there are some provinces that have high number of urban population, such as Riau Island, and then Bali and East Kalimantan. And then now we focus on the city in Java Island. We can see here that the number of the urban population is concentrated in some cities that is usually a capital of the province, such as Tangerang City, and then Jakarta, and Bandung City, Bekasi, Depok, Semarang, and Surabaya. And then if we talk about the density, there are some cities that have a highest density population in Java Island, they are Jakarta, Cimahi, Bandung, Tangerang, and Bekasi. Talking about the condition of water supply and sanitation, we can see here that not all of the population have access to drinking pipeline drinking water supply. We can see here that in 2018, in urban area, there are 18% of population have access to pipeline water supply system, whereas in urban area it's only yes, around 62%. Also, we can see here that the access of urban population to drinking water is better in urban area compared to rural area. This is the average of access to improved drinking water supply in Indonesia. And then if we talk about the distribution of access to improved drinking water, this is, yes, little bit different from the distribution of population, where the urban population is concentrated in Java Island. But if we talk about the access to improved drinking water, this is relatively well distributed. I mean that, yes, it's around 60 to 85 or 90% of population in each province has access to improved drinking water. The condition of improved sanitation is more or less the same with drinking water supply. It's yes, but I mean that the rural area has less proportion have access to improved sanitation compared to urban area. And then if we talk about the system, most of the sanitation system in Indonesia is decentralized system. It means that it's not centralized, so it's and also it's a combined system between stormwater and wastewater. And also the distribution of improved sanitation is also the same as drinking water, but we can see here that West Java has less access to improve sanitation according to the proportion of population to the total population. Yes, but we can see that the distribution is more or less the same. This is between 65 to around 95% of population have access to improved sanitation. Now we talk about planning document that it's related to urban water. In Indonesia, we have a spatial plan that started from national level and then province level and city and regency level. The spatial plan in low, if I can see here, if I can say that this is a lower classification, has to refer to the higher level of spatial plan. So just for example, spatial plan in city level has to refer to the province level, and also the province level has to refer to the national level. And then the spatial plan in Indonesia is regulate the land use and also infrastructure. And this is a long-term plan for 25 years. And then besides spatial plan, we also have a sectoral plan. Here, I start here, maybe in Indonesia, we have water supply master plan, and then solid waste master plan, sanitation white book, and also drainage master plan. And this is usually in the level, in the city or regency level. And according to the regulation, I mean the procedure that all of this sectoral plan have to refer the spatial plan. And also the obligatory to provide public water supply is also in the usually in city and regency level, although in some province there are some regional water supply system, but most of the system in Indonesia that public water supply is in city or regency level. And then also in Indonesia, we have a water resource management plan, or in Bahasa we call document pola, and it's regulate the water resource system in national, province, and also city regency level, because this is it's a inter-regional plan, or it's because the basis is not the administrative region, but the basis for water resource management plan is the water set. So it can be there are several administrative region in water resource in certain water resource management plan. And then in the local level, Professor Bao also explained the different level in implementation of sustainable water supply water supply system that also happen in Indonesia. That also we have a community-based plan. This is not formal plan actually, but some communities also make their own plan in order to provide the water supply and also sanitation system for the community. Some of the community also have got the assistance from the government or NGO. And then if we talk about the implementing actor, there are many implementing actor, but we can divide into government, private sector, including developer that also have the obligatory to provide infrastructure in residential area, and then community and NGO. Yes, if we talk about the implementation of the plan, there are several issues actually. The first one is related to coordination. Professor Baskaran also mentioned about the integration or integrated water supply management. This is also issue in Indonesia because if we back to this slide, there are many plan and this is look very sectoral plan because we have water supply master plan, solid waste master plan, sanitation with white book, and also drainage master plan. And also if we talk about the actor, there are many actors involved in the implementation of water supply plan. Yes, and the second one, it's also related to coordination, is integration, both between sectors and also region, because most of the plan is has a boundary of administrative region, but we know that water is not flow based on the administrative region. So this is also the issue in Indonesia, how to integrate the sector and also how to integrate the region. We have the upper stream region and also the downstream region, how to integrate the plan between this region. And then the third one is that the policy in each city and region are not the same, and sometimes this is depend on the leader. Yes, the leader have to have the leader that has a very strong environmental vision. They will give a very strong emphasis on the sustainable urban water management. And then the fourth one is the new concepts such as green infrastructure, low impact development, or water supply, water sensitive urban design. Implementation is still limited in Indonesia. And then the fifth one is we talk about the scale. The implementation of the concept of low impact development or water sensitive urban design is more in the small scale implementation, or in if I can say it's in neighborhood level, household or community level. And then the last, of course, it's related to financial aspect, because not all of the program and activities that already stated in the plan can be implemented because of the financial limitation. I would also show here some studies that we have have been done in our research cluster related to green infrastructure in metropolitan Bandung. we have make some study related to large-scale green infrastructure about the possibility to implement the large-scale green infrastructure in the Cisangkui Basin, Cisangkui watershed. So we found here the first things that we try to make a modeling by using GIS to map the location and also the type of green infrastructure that is possible to be implemented. And then after that, we check the land status of the location for the green infrastructure and also the spatial plan. So we found that the implementation of green infrastructure in large scale, for instance, in the watershed scale, it's limited to the land ownership because especially in this Cisangkui watershed, the land is already occupied by the private, I mean the household, because in Indonesia the land status is belong to the individual or private land. And this
Busri,
is
sorry to interrupt. It's
okay.
about 1 or 2 minutes left.
Yeah, thank you, Bu Nini. And also the spatial plan. And our study also in related to green infrastructure and spatial plan in location for the green infrastructure. Yes, and we found that the green infrastructure measure has been accommodated in spatial plan actually, but limited only in some measures such as green space and bioretention. And then our last study is related to the willingness to implement green infrastructure in informal settlement. This is in macro level study, and we found that the income level is influenced the willingness of community to implement green infrastructure in informal settlement. Yes, I think that's all from me. Thank you very much.
Thank you very much, Busri. You bring us to the different side of water management from the global south perspective. Thank you for introduce us also to different levels of policies and also intervention. We will get back to you, Bu, after the final presentation. Thank you. Now we have the final presenters for the main session from Dr. Kusuma Rukmi from Development Planning Agency of Bekasi Regency. Dr. Rukmi is the planning analyst in Development Planning Agency of Bekasi Regency, Indonesia, and has been working there for local government planning agency for more than 10 years. Dr. Rukmi completed her undergrad degree in statistics and obtained master degree of urban community and regional planning and obtained a PhD in civil engineering. Dr. Rukmi focus are in natural resources, environment, and urban water management. And Dr. Rukmi now is a reviewer for Utilities Policy Journal and also Water Resource Management Journal, and also a reviewer for IWA conference. Now I invite Dr. Rukmi to bring your presentation.
Thank you.
The screen is yours. Yeah.
Let me share my screen. Yeah, can you see the screen now? Yeah, can you see the screen now?
It's on the way, I guess.
Okay.
Yeah.
Yeah.
All good.
All good. Okay, thank you. So yeah, I come from the local government, so I will talk about the local government proportion of talking about sustainable urban water management. And we are now talking about the sustainable development goals, especially talking about the drinking water target. Yeah. Okay, please. Yeah. So let me explain you, maybe some of you doesn't really update it with the Sustainable Development Goals drinking water target. So in global, we are talking about the drinking water target, which is the United Nations wanted that everyone in the world, the global population, will have the same access to drinking water, which is they said it is safely managed drinking water. What is actually safely managed drinking water? It is water come from improved water sources that is accessible on premises, available when you need it, and free from fecal or chemical contamination. So it's actually the water that you got in Australia, for example, where you can drink the water directly from tap. You don't have to boil the water. Okay. But before going to the safely managed drinking water, the United Nations understand that not every country can provide this safely managed drinking water. So they provide some ladder to make some countries more like can describe in which ladder they are. So we have the safely managed drinking water as the top, the highest level ladder. And then we have the basic drinking water source, which is water from improved water sources that you can collect in at least 30 minutes. So if you have the water source outside your house, you don't have to take like 1 hour to get it to make us classify you as having a basic drinking water source. And we also have limited drinking water where you have to like walking too far away to fetch water, or you are in an improved drinking water source if it's come from the duck well, unprotected duck well, or unprotected spring. And you can also get water from surface water, which is the lowest ladder of drinking water sources. Yeah, so how about improved water sources? Which one do we classify as improved water sources? In the Millennium Development Goals, we only consider pipe water sources and then boreholes. We don't count water in bottle as improved water sources, but now in Sustainable Development Goals, we count them as improved drinking water sources. So we can get water from pipe supplies, or we can also get water from non-pipe supplies, and we consider them as improved water sources. We here is the United Nations, of course. So now let's get to Indonesia. How the government efforts to expand and improve water supply services in Indonesia. Yeah, so when we see the safely managed drinking water, there are 3 indicators that that provide indicators that you can count as safely managed drinking water, but you must be accessible, and you must the source must be accessible, must be available when needed, and must be in good quality. So there are 3 indicators. Let's see from the first indicator, accessibility. The government of Indonesia has provided the first priority of water allocation is for the household use. It usually comes from the groundwater. It means that when a household wanted to fetch water from groundwater by making boreholes, for example, they don't have to get permit as long as they use it only for household daily use. So that's why maybe we will find that most of Indonesian households get water from groundwater. Government also provide fundings for pipe water supply services to expand. For example, in Indonesia, we have, like in Melbourne, you have Melbourne Water, Barwon Water, etc. They are usually government owned, yeah? So in Indonesia, we also have PDAM, so Perusahaan Daerah Air Minum, which is the government-owned company that provide pipe water supplies. All the local government always support this company, their own companies, to expand the pipe water services. But instead, not only with public company, the government also provide funding for the community-based water supply institution, like Bu Sri already told you before. So every year we always provide funding for the community-based, for community to provide their own water supply. It usually comes from the confined aquifer, so they have like this water tank. They got it from the groundwater, and then they distribute the water to nearby residents. And the third one is that the effort to expand the accessibility is by allowing private companies. So some private companies can provide pipe water supply. For example, in Indonesia, there are not in every city they have the private companies, but in Bekasi we have several private companies that provide pipe water supply to some residential complex. And then there are also water kiosks and bottled water companies. Water kiosks, maybe you don't find it in Australia, but it usually in developing countries like in Indonesia or in Africa, you can find some kiosks that provide refill drinking water. So you can bring your own container and refill with the drinking water. So this is the tap water quality. You can just drink it directly without boiling it. Yeah, so talk about the availability. If we see the accessibility indicators, the government trying to expand the drinking water sources for the population. And then when we talk about the availability indicators, the government only provide this availability, only see the indicators of this one only for the public company, for the PDAM themselves. So the Indonesian government has a regulation for the public pipe company to provide water so it can be available for everyone when they need it. For example, the government will assess the performance of the public companies. So when they their operational hour is less, they have less score. But when they can provide water like for 24 hours, they can get a higher score. That's also with the water pressure. If they can provide good water pressure for every customer, they will get higher score. But if the water pressure in most of their customer is low, and then they got a lower score. So this is the effort to make sure that water is available when needed. But the government regulation is not applied for every companies that provide water. For example, if there is private water companies that provide pipe water services to some residential area, the government did not take account to their availability services. But it's their own private companies' effort to supply water in 24 hours and in a good pressure, because if they perform lower, then the customer will be complaining. Yeah, but the government would not give any complaint to them if they provide less hours, for example. Okay, so continue to the quality. For the quality side, the government provide the regulation to maintain the good water quality for every institution that provide water for the population. So there are two regulations. First one is the drinking water standards, and the second one is the procedure to monitor drinking water quality. The Indonesian government drinking water standards come from the United Nations drinking water, what they called it, quite like a bit like standards. It comes from the United Nations, so it's the same. It's the same with what applies in Australia, for example. So it's not a lower drinking water standard, but it's the same drinking water standard for the other countries. So again, even though the government has already provided regulation in procedure of drinking water standard, the government only assess for the public water companies. So when the public water companies do not perform well in water quality samples, the government will give a lower score. But when they perform well in the water quality samples, then they will get a higher score. The score will be used to evaluate the whole assessment of a public water company, and then it will depend on your scores. They will classify public water companies as healthy or as sick. So when you are healthy, you can get any loan from the government, you can get more grant from the government. But when you are sick, the government will provide an assistant to make you perform better. But it doesn't apply for the private water companies. It's only apply for the private water, for the public water companies. Okay, now we'll get back to Indonesian SDGs update. So when we see here, the Indonesian Sustainable Development Drinking Water Progress, we see that almost 90% of Indonesian population got water from at least basic source. Basic source means that the water comes from improved water source, and you only have to go like no more than 30 minutes to get it. So it can come from the pipe water on your premises. It can come from pipe water outside your house, but you can take it less than 30 minutes. Yeah. And there is also some population that got water from limited source, from an improved source, or we still have like 1% population that get water from the river, from surface water. We've been doing better from 2015 to 2020. Now there are 92% of the Indonesian population get water from at least basic drinking water source. But when we go back again to the United Nations aim to get all the global population get water from safely drinking water sources, apparently in Indonesia, we can only provide water at least at basic. It doesn't mean that there is no population got water from safely managed drinking water source, but the data only show that about 92% of Indonesian population get water from at least basic source. At least they got water from improved water source, and they only take like less than 30 minutes to get the water. When we see again the safely drinking water management, safely drinking water sources, asked that water should be accessible on premises, available when needed, and free from contamination. When we see the United Nations report about drinking water in 2020, Indonesian government cannot provide the data of free from contamination data. They can only provide that, okay, our population got water from accessible on premises, which is the pipe water system or the duct well inside the house. And then they're available when needed. They can provide this data. But the Indonesian government cannot provide the free from contamination data. Why is that so? Because when we see that some of the population already get pipe water services, in our mind, every pipe water services will be monitored. The water quality will be monitored frequently. But why they cannot provide the data? Okay, let's see. In this part, I will show you how it works in the local government. We will get study from the Bekasi. So I held a research in 2019. I collect samples, 79 samples from some household drinking water sources. So it comes from the PDAM, which is the public company, and some private companies that provide pipe water services, and then from community-based water supply institution. And I also get some water samples from household who get water from groundwater. So it takes like 79 samples for all of them. Apparently, from all the samples, we see that only 16% of the samples following the drinking water standards. Well, actually, it's a good sign for me because, okay, we still have some of our providers that provide water at drinking water quality. It means that when you get water from the water tap, you can drink it immediately without boiling it. But 80% and more still provide water below the drinking water standards. Okay, so this plot here, it includes water from the community-based water supply, which is provide groundwater from confined aquifer and then deliver the water without treating them. And then it also includes groundwater that is used by household. So I think it's not fair enough here. So I make another plot that provide water from the institution, from the companies that provide water, provide treated water. So this is include PDAM, the public water company, and then the private water companies that provide pipe water services. From this data, we can see that more than 21% of the samples is at drinking water quality. And then 78% of the samples is still below standards. Below standards is usually they still high in total coliform, or there are some that nitrate or nitrate is higher than the drinking water standards, like that. So this is what happened in the real world of Indonesia. So that is why we as Indonesian ourselves usually do not have such a confidence to drink water from the tap. Usually like this, I have to boil water first before drinking them. Yeah. So what's the matter actually? So when we see, this is from my PhD thesis, apparently, even though the government already provide regulation for each water supply providers to conduct water quality monitoring, not all of the providers conduct it at the standard required. Some conduct the monitoring, but not as frequent as asked, or the number of sample is not as the amount expected by the government. And then the other reason is that when the monitoring was conducted, the result is not used to immediately correct the problem. So there is the public water companies that always conduct water samplings every month, and then the result will come like 1 week or 2 weeks, and then they don't have to do anything if it went wrong, because it's already 1 week later. So they don't use the data to correct the problem in the distribution system. And also there is lack of awareness among the water supply provider of the applicable standards and how the standards be attained. Like some of the water providers think that they don't have to provide water at customer tap on drinking water quality. They just said, I just have to provide the clean water to the customer. Oh no, you don't, the governments do not say it like that. The government said that you have to provide drinking water standards at the customer tap, not at your reservoir. Mostly the pipe water companies will provide drinking water standards at the reservoir, but from the reservoir to the piping system and then go to your tap, it's not their concern. As long as it's not poison, it's okay. Okay, and the last one is that water quality surveillance, which should be conducted by municipal government, that's my government, is also absent. So our health agency only conducted surveillance only for the PDAM, the public water company. They do not provide annual monitoring to the private companies, which is actually in the regulation, it's said like that. So what should we do? So first thing first is that it is the local government themselves should provide a good surveillance on drinking water quality, especially for the pipe water supplies. If at the moment it's already done for the public water suppliers, then they should move to the private water companies. And then the first thing is that all stakeholders should be at the same goal to deliver drinking water up to customer tap. Because when I'm discussing with my colleagues in the Ministry of Health, they said that that all the water supply providers should provide drinking water quality, but that's not the practice at the moment. And then the water
Sorry,
supply.
Bu Rukmi, you have 1 or 2 minutes left. Thank you.
Okay,
Sorry.
this is the last slide. So the water supply provider themselves think that they don't, it's not their duty to provide water at drinking water quality. So there is a gap between the highest level government and the people that provide the water. So it should be at the same goal, so they can reach the goal that they intended to. Okay, I think that's all for me. Thank you for listening. Yeah.
Okay.
Back
Thank
to you,
you.
Bu Ninik.
Yeah, thank you, Bu Rukmi. Very rich presentation. Apologize. I think I was thrown out, kicked out at the beginning of your presentation. But yeah, so Bu Rukmi actually bringing further what Bu Sri explained about different systems in Indonesia, and Bu Rukmi provide us real examples on the ground, yeah, Bu, about the dynamics of water management and also basically water provision. Yeah, thank you for all speakers again for great presentation. Now, if we look at the chat box, I believe we have many questions raised for you. Shall we go one by one, or any one of you would like to address one of them or one or two of them? Yeah.
I think it would be good to go one by one, I think.
Oh, okay. Okay, Bas. Yeah. So first question from Aris Purwanto. Aris Purwanto, you want to raise your question again directly to the speakers, or shall I read it for you? So, yeah.
Yeah, just read it
Okay.
for us. Thank you.
Okay. So Pak Aris asking about, in managing water, coordination is common sense, but not in common practice yet, especially in many developing countries. Additionally, in countries with decentralized system, administration border and perspective and role sometimes are stronger than river basin and watershed approach. I think this been raised by Professor Bhaskar and also Bu Sri Mariati, I believe. And your question is, should we manage water in the upstream, downstream, and urban areas only by one centralized institution? Yeah, that's the question from Aris. And I invite now Professor Bhaskaran and then Bu Sri Mariati to comment on this question.
Yeah, thank you. And it's a challenging question because very often the different departments and different organizations create their own silos and they don't want to talk to each other. But we need to look at much broader contextual side. If you want to manage the water properly, we have to incorporate all these stakeholders. And the implementation is the challenging. It's not going to happen overnight. It's a long-term process. As I said, it's a paradigm shift, and particularly in Victoria, I would say it taken us about 10 years to get to this level. But that is driven by, we have a 10-year of drought, there are water restrictions and so forth at that time, but also the water quality aspect of it. But very often people don't look at the quality of water supply and the quantity of the water supply as a direct correlation of the health of the community. We spend a lot of money on the health of the community in hospitals and medication and all of that. If you provide a adequate quality and quantity water to the community, you could save a lot of money out of the health system as well. And so it's not only the people who are involved in the management side of water to coordinate, then we need to look at more at a regional government level or a federal government level. And we do had a similar situation in Australia where each of the states or provinces have their own water management system. But also it has to come with the community education aspect as well. Community awareness and community education is an important across all levels, including the industries and so forth. And I think Rukmi pointed out that implementation is an important aspect as well. Yes, we can have the planning and regulatory requirement. Who monitors it? And if you don't monitor it, it doesn't happen as well. So it doesn't have to be a centralized institution, but all of these stakeholders have the willingness to collaborate is an important aspect rather than having a centralized system. It can be done at a regional level very effectively, but the government need to drive that collaboration and then to some extent incentivize this sort of collaborative approach rather than an individual one.
Thank you, Bas. Now I invite Bu Sri to give some comment, Bu.
Yes, thank you, Bu Nini. Yes, I totally agree with Professor Baskaran, that especially for Indonesia context, that is very big nation, and also there are many population, and we have 34 province. Yeah, so it's look impossible to have a centralized institution for arranging the urban water management. But also I totally agree with Professor Baskaran that we can strengthen the how to collaborate between institution, between stakeholder. And also I think the important thing in Indonesia that we also have to strengthen the guideline for each institution, because 2 weeks ago we have a focus group discussion with local government in Cirebon. We also explore the mechanism of collaboration and integration in providing water in that region, and we saw that there is a problem of communication, and also then we come to the conclusion that we have to strengthen the guideline, that every institution have to refer, for instance, the spatial plan that produced by the spatial plan institution, and also how they can collaborate each other. Yeah, I think that's all from me, Bu Nini.
Okay, thank you, Bu Sri. And I guess this also answer the second question from Sukma Utami about the key factors that contributing. So it's not only one way going, but more to collaborative and integrative ways. And now we go to the next question from Devi. How is the role of developer in providing sustainable urban infrastructure in Australia? Now I invite Lloyd and Bao to have some comments, please.
Sure. I'm happy to go first, if that's all right, Lloyd.
Yeah, I think you're probably better placed to answer this, both. So I'll leave it to you.
Okay. Well, it's an interesting question, the role of the developer. I have to say it really depends. You can have a very enlightened developer who really takes integrated water management, water sensitive urban design seriously, and incorporates that into the that planning permit or that precinct level in their developments. On the flip side, you can have a developer that will just do the bare minimum, if that, and if you want to say local council that will ultimately take responsibility for the implementation measures that a developer puts in place, really has to keep an eye out and monitor and ask the developer to do more. So it unfortunately, it kind of depends on the developer itself, whether they are really on board, they want to incorporate this, or whether they see it as a requirement that they have to fulfill. So it's kind of, there's two different ways of thinking about that or approaching that question. Thanks. I hope that helps.
Yeah. Thank you, Bo. So we go to the next question, and now to the academics from Deakin again. Yeah, the first question is about community involvement. I think it's been answered in the previous question. And the next question will be again to Professor Lloyd and Bao. What do you think about technology that we have? How can it adapt to the improvement of water management? We have obstacles regarding limited funding and governance capacity. So maybe I invite Lloyd first to answer the question, and then after that go to Bo. Yeah.
Okay, thanks, Nini. I think in the context of WSUD, for example, definitely the technology is available. I mean, the examples that I showed you just now, work done by my PhD student, for example, we are now able to model accurately the processes that are happening. The problem, I think, the issue, and I've worked with a lot of our local governments, both in Australia and overseas in Southeast Asia. I think the problem is that there is a disconnect between decision makers, those sitting at the government level, those who are involved in policy and all that. there's a disconnect between the decisions that they're making and what is, the people like us, who have the technical expertise, because I don't think there's a full understanding of what's out there, what we are capable of doing. That's the first thing. The other issue also is that many of these systems, when they are built, they are not maintained at all. So the systems fail not because the systems do not work, but the systems are not well maintained. For example, if you look at Indonesia, you have a line, your drainage system is a line drainage system, and is able to convey all your floods and all that. That's not a problem. There's no maintenance at all. Once you move into WSUD, then there needs to be a shift in the thinking, in the way you manage such systems. In Australia, for example, council is, the question on developers, with each development, there are more and more such systems coming in place. And of course, costs goes up because you need to manage all these systems. So the problem is this: do we really need all these systems in place? Do we really need to have 101 assets? And I think this question needs to be answered, needs to be asked, and needs to be answered. And I think to answer the question, we need to ask ourselves, what is the purpose of having WSUD? Now, one of the main things about WSUD, of course, is the water quality perspective, right? And we need to understand what is the impact, downstream impact, let's say, of runoff, urban runoff from a particular catchment or a particular city or particular area of a city. We need to look at those impacts. If, let's say, the runoff is going into a stream or a lake, which is very pristine, and has a kind of fish that is only in that lake, nowhere else in the world, then we need to be more stringent in the application of WSUD. But if not, then we may lessen, we may not put so much emphasis, or we may have less of these kind of systems in place because the need is not as stringent. So there has to be an appreciation of, there has to be a more targeted application of such systems with respect to the ecosystem, in which we are working in. So there are many aspects to the problem, but as I said, the technology exists, and all these things, we have technology to answer all these questions. Bo.
Thank you. I'll just, Lloyd answered that really, really well, and I'll just pick up one thing that he mentioned. It's the management of those. So yes, we have the technology, we have the models. I showed you a number of different illustrations from the domestic application all the way up to the streetscape, and Lloyd showed you bigger models as well. But at the end of the day, it's people that still have to take care of those. They have to manage those systems, and that's where we sometimes fall over. I know in local councils on the outskirts, on the urban fringe, if you want to say, of Melbourne, the maintenance teams really need to be upskilled in order to understand and to manage these systems, to take care of them so that they can, I guess, provide the clean water in a sense that protects that fish that Lloyd was providing the example for. So it's the technology is there. We have a range of strategies to apply, but again, it gets back to us, the management teams, that have to take care of them and make sure that they work properly, or they just fall in, as we would say here in Oz, a heap, and they don't service or do what they were originally designed to do. So I just wanted to kind of talk about that little management dimension that Lloyd mentioned a bit more. So thank you.
Yeah, thank you, Lloyd and Bo.
That's okay.
So it's so it's not only about the financial issues, but also the management and also the human resources that handle it. Yeah, it will be the key factors that we like to address. And for the last two questions, I believe they are go to Bu Sri and also Bu Rukmi. So firstly, from Susanti Widyastuti. Susanti, question about interesting to see how the WSUD in cities of Australia. In Indonesia, we must to renovate the built areas, especially our roads and pathways, which is limited to be possible to make over. What do you think about practicing WSUD in the built areas? And the second question from Dwi Fitri, questioning about what is the main obstacle on implementing the water SUD concept in Indonesia? Is that true that we have to change our paradigm first to involve natural element to urban water cycle? So firstly, I'll invite Bu Sri to answer the question, then go to Bu Rukmi.
Yeah, okay, thank you, Bu Nini. Maybe altogether the last two questions. It's how to, yes, this is the problem, yeah, in the built up area, as I saw in my presentation, that the main problem to implement green infrastructure concept or measure is the land availability. And this is the problem in built up area. But we, of course, we have a solution. Yeah, we have technology, as Professor Lloyd and Bao mentioned. At least we can use, because of the limited of land in built up area, we can implement such as rainwater harvesting by using rooftop. Yeah, this is just for instance. I mean, yes, of course, not all of the green infrastructure measure that we can implement with the limitation of land, yeah, or in the built up area, but we can innovate with the technology, or we can choose one intervention, yeah, that it doesn't need the very big plot of land. But of course, if we would like to implement this in the macro scale, this is very difficult. Maybe my suggestion is we can start from the local scale, from neighborhood, from household. Yes, maybe that's all from me, Bu Nini.
Okay, thank you, Bu Sri. So now to you, Bu Rukmi.
Yes, thank you. So when we're talking about water sensitive urban design, actually, I think it will be quite difficult for our government to implement it in like a zone area or a new developing area, because we still like busy with the conventional work, yeah. But when we talk about what can individual or institution do, actually in Indonesia we have the Green Building Council. So it's like a certificate that gives certificate to a building that considered as green, and water is one of the indicators that that was counted for get the certificate. And we already have some building in Indonesia that already got that certificate. It means that they already applied the water sensitive urban design, but in a building. So they harvest rainwater and then use for like watering the plants there, or some of them also use for flushing the toilets or others. But it also being used, that's for one institution. We also, as an individual, we can also implement it, like Bu Sri said, that we can also implement it, the water sensitive urban design in our house, for example. That's the easiest way to do that. So in my house, for example, return from Australia, I built a simple rainwater harvesting just because I can use them for watering the plants. I think like that, Bu Nini. Thank you.
Okay, thank you, Bu Rukmi. Really, so Australia is a really great place to live here, yeah, and to learn.
Yeah. Sorry, Nini.
Yes,
Nini,
yes, Lloyd.
Can I make a quick, just a quick 1 or 2 sentence addition to the answer?
Yeah, sure.
Water sensitive urban design, I think it's a good question. What's the main obstacle? I think one of the main obstacles is people. We need to change we need to educate, ourselves, our mindset. For example, because I work in the region quite a bit, I've seen, for example, cases of constructed wetlands, bioretention basins. What do the people do? They use it as a rubbish. They throw the rubbish, So you have a nice lake that is being constructed, and then it's used as a rubbish bin. Everybody just throws their rubbish there. So the buy-in from the community, what Bas was talking about, the social thing, that is really, really important. We need to get people involved so that they understand what this is for and how it benefits their community. That is key, But I was in Vietnam just before COVID. I was in the south of Vietnam in the province of An Giang. And the people there, they put all their rubbish in small bags and leave it on the road. And then the rubbish truck comes and the man takes the rubbish away. I can say, in all my travel around Southeast Asia, is the cleanest city that I've ever visited. So I think it can be done, but we need to educate, the people, and we need to have the right mindset. Okay, thank you very much.
Thank you, Lloyd. You just highlighting the most important factor as to the success. Yeah, the people, the people. Yeah. So really, it's not only about technology. It's not only about the system, but yeah, the men who run the system, the men and ladies, and who run the system. So thanks again for all speakers for very rich presentation today. I hope all of participants, they can get the most of it. And before we go to the student presentation session, I'd like to conclude the presentation of today and also the discussion that firstly, now we're facing a paradigm shift regarding water urban management, and some of our speakers also introduced the importance of water sensitive urban design, which is also contextual in Indonesian condition. And also, again, the importance of integration and collaboration, and also lastly, as highlighted by Lloyd, that we need to educate and need to support the people who's running it. Okay, thank you everyone for staying with us up to now. Now I hand it over to Jovita for the student presentation. Thanks again, everyone. Thank you.
Thank you, Bu Ninik. So we are going to move to the next session, the presentation session. This is the list of the rooms. We have 3 rooms, the main rooms, the room 2 and room 3. And the moderator will assign the lectures and the presenters to each room, and the other seminar participants can choose their rooms for the presentation session. Now, for all the moderator, please assign the presenters and the lecture. Thank you. Good morning, good afternoon, everybody. Welcome to the presentation and discussion session for Group 1. We are here in the Group 1 for a discussion and presentation. Before we begin, let me introduce myself. My name is Sukma Utami as the moderator for the session. And we are here, we have two lecturers. The first lecturer is Professor Baskaran from Deakin University. And the second lecturer is Dr. Sri Mariati from Bandung Institute of Technology. Before we start the presentation, I will read the list of the presenter today. The first presenter is Mr. Arif Asri Samsu from Bandung Institute of Technology. The second is Mr. Deepak Malia from Deakin University. And the third is Mr. Teddy Kurniawan from Bandung Institute of Technology. And the fourth is Mr. Miss Kopal Duta from Deakin University. And we hold the discussion until all presenters finish their presentation. Actually, we have 40 minutes for our discussion and presentation session. It's include the discussion and the feedback from our lecturers. And now we may start our presentation. For the presentation, for every presenter, we only have 5 minutes. And I will give a sign if the time is less than 1 minute or reach or the time is up. For the first presenters is Mr. Asri Syamsu from Bandung Institute of Technology. Mr. Asri Syamsu, the time is yours.
Thank you very much for this opportunity to present my basic proposal idea related to integrated urban water management and planning in Indonesia. For this introduction, there is the Dublin Principle has become the foundation of the agreement to emphasize the importance of integrated water management in the Agenda 21st. In addition, there are so many problems in water management that Global Water Partnership refers that need for a new approach to water management. In implementation, putting key stakeholder in the table for planning and decision-making process, and this is a significant principle of integrated approach. Therefore, identifying key stakeholder and their role is an important factors toward integrated approach in urban water management. But to identify those stakeholders, integrated planning framework approach identification also is needed first. Integrated approach for urban water management is developing with several terms actually which have the same spirit for water sustainability. However, the integrated urban water management is not only about viewing the different urban water components as integrated physical system, but also emphasize the relevance of considering the broader natural landscape and its social institutional structure. Therefore, the focus of my study is on the integrated urban water management approach from the point of view of the planning process. And one of a principle of integrated urban water management is the how to align formal institution and informal practice. And to achieve those goals, there are several planning frameworks that was built in different planning approach, such as integrated urban water management planning framework, CLTM framework, and MPA pass method. No, actually, I'm still make a progress to get more planning framework related to integrated water management. But in the table, we can see that as a strategic planning, integrated urban water management and CLTM framework use technocratic approach, and it will affect to limitation opportunity for stakeholder participation. But in the other hand, total community involvement such as in PAPAS will face the difficult when dealing with specific problems and specific solutions that need a rational process. Therefore, this study also will observe the best approach in Indonesia, bottom up or top down, or combine those approaches to get wider community involvement. The research methodology that will be used in this study is a MIST method that starts with a comprehensive literature review on integrated urban water management to provide the basic concept of the research and framework. In the process, as you can see, there are case study, conceptual planning, and survey. And hopefully in the final stage, the data from the qualitative and quantitative will combine and show the findings. In general, in Indonesia, to achieve 100% goals in both water and sanitation divided into two ways, technocratic and community-based approach. But in terms of planning, out of their content are elaborated in strategic development part. There is the plan. There is a difference plan related to water and sanitation. And both water and sanitation plan are arranged in Pokja IMP as a working groups for stakeholders from government and non-government related to water sanitation. It can be clearly seen that there has been a shift from traditional approach to integrated approach. And Indonesia, there is an institutional integrated for water and sanitation that called Pokja MPLU produce a plan related to water and management. However, documents are fragmented between water and sanitation. That's why there is an urgent need regarding integration for all planning process and stakeholder aspect related to water and sanitation. I think that's all. Thank you very much.
Okay, thank you for Mr. Ashri Samsu for your very comprehensive and interesting way. And now we move to the second presenters. We have Mr. Deepak Malia from Deakin University. For Mr. Deepak, the time is yours.
Thank you. I just share my screen. Is the screen visible, ma'am?
Yep, all good.
Yes.
Yep. Hello, everyone. Most of the presentation in the ITB seminar is going to be based on urban water management, but in terms of our work, it is a bit different, and it is going to explore the advances in nanotechnology and membrane science for water treatment process. So water treatment process is also going to be a very important aspect in urban water management, because this water treatment process is going to allow us to provide safe and clean drinking water. Our research work is a multidisciplinary effort involving material science, polymer chemistry, and water treatment analysis to solve the world's major problem of providing safe and clean drinking water to all. Do you realize that for billions of people, having a cup of safe and clean drinking water is still a luxury? Humanity is facing a water crisis, and we at Deakin are stepping up our efforts to resolve it. Lakes, rivers, and groundwater are the key sources of drinking water in various countries, including Australia, Indonesia, and India. But there's a problem. Dead leaves, damaged plants, and algae, bacteria in the water all react with each other and release organic waste products into the water, which gives a brown color, unpleasant taste, and foul odor to the water. During water treatment process, chlorine added for the disinfection purposes reacts with these organic substances to form carcinogenic byproducts. In order to make the water potable, these organic substances have to be eliminated. Currently, nanofiltration membranes are preferred technology to remove these organic substances, along with a lot of other heavy metals and the emerging pollutants from water. However, the commercially used membranes has a major drawback, that is organic fouling. Do you recall the organic substances I mentioned before? They deposit on the membrane surface and prevents the flow of water through the membrane. They also facilitate the growth of microorganisms, leading to the degradation of membrane. Consequently, the membranes have to be cleaned at frequent intervals with corrosive chemicals, and often they have to be replaced, which makes the process very expensive and unviable. Hence, several research work focuses on modifying the membrane surface to impart desired properties to the membrane and improve the fouling resistance and the performance, thereby improving its cost effectiveness and energy efficient production of drinking water. This is where my research will make a great impact. I am incorporating functionalized 2D MOS2 nanosheets with exceptional properties during the membrane fabrication process. We use a simple and novel, environmentally friendly synthesis process using a sugar-assisted ball milling technique to produce these nanosheets. Our research work involves incorporation of these nanosheets during the membrane's fabrication stage. We are following 2 or 3 strategies and exploring them and incorporating the nanosheets. Our initial results have helped us understand that the incorporated nanosheets is actually able to improve the surface properties of the membranes, including hydrophilicity, charge, and surface roughness. So these properties, once we are able to tweak these properties, the performance of the membrane is improved. So we were able to observe increased water permeance and increased fouling resistance of the membranes. This decreases the cost benefit or cost impact on the process. In conclusion, our 2D modified membranes has 3 main advantages when compared to the commercial membranes. One, it prevents the deposition of the organic substances on the membrane, giving it a long operational life, thereby making it more cost effective. Secondly, it removes the organic substances with higher efficiency and eliminates carcinogenic risks in potable water. Energy consumption is drastically reduced, thereby making it more economically viable. My preliminary findings indicate that the next generation membranes we are developing will take us one step closer in realizing our goal of making safe and clean drinking water available to all. Thank you.
Okay, thank you, Mr. Dipak, for your very interesting presentation. And now we move to the third presenters. The third presenter is Mr. Teddy Kurniawan from Bandung Institute of Technology. Please welcome Mr. Teddy Kurniawan.
Okay, thank you very much for the time, Ibu Sukma. I will share my presentation. Okay. Good morning and good afternoon to the lecturers and the attendees of this seminar. So this is, I'm gonna talk about something called dam infrastructure, which is in this related presentation, I'm just gonna talking about how dam infrastructure is operated by the alternative funding source from the tourism activities, because we all know that there is a very limited public funding for infrastructure with nowadays, of course, with the pandemic and the others issues in the end. So this is more related to governance issues and the economic funding issues for the infrastructure. Okay. Okay. So a very brief introduction. This is one of the dam infrastructure in the Indonesia, which is located in East Java, Malang City. In this dam infrastructure itself, it uses for irrigation system, also used for intake source for clean water, also used for hydroelectricity power, which is converting from the water source to the with water electricity generator to electricity for powering up the electricity for Java and Bali Island, and then in this dam infrastructure itself also utilized for tourism activities for the local communities, and also it is a very old building which is constructed in 1970. Yeah. And this is a very brief little review as my maybe as my source of inspiration to how it is, because there is a definition of dam and the tourism itself and how it can be compared to sustainable development, because as we all know, dam infrastructure is not user charge friendly, because it is not a user charge infrastructure like in water distribution or in electrical infrastructure, because the main utilization for dam infrastructure is only for flood prevention, which is then converted to multi-purpose dam. Then it can be utilized for many others like irrigation and hydroelectric power, as I mentioned before. So tourism in dam infrastructure is a profitable business activity which using dam and surrounding nature, because as the main attraction, because with the huge main body and the main water body and the surrounding nature is a very high potential to become a tourism activities there. So this is one of the approach that we can use to helping the limited public fund that we use for operational and advanced development for the dam infrastructure itself. So this is the discussion and methods that I'm in. So I'm gonna focus in this diagram, which is it is happened many cases in Indonesia, because dam infrastructure is often located in the very remote areas, which is of course close to the forest and the nature areas, which the local community have a fisheries agriculture activities as their main source, and huge water body reserve natural surrounding, of course, and the dam infrastructure needs an alternative financial source, and besides public fund source, which is a very limited, as we all know. So the tourism side is one of the approach that we can use by utilizing the potential and the problem that we have faced nowadays. And also this is related to the sustainable development goals, which we all know in number 6, number 8, and number 17. Because of course the dam infrastructure can be a source intake, which provided clean water sanitation. It also can provide a work for the local communities and the partnership institution for the local government, the water management agency, which is PDAM in Indonesia, and also the partnership. This is the Karangates Dam that this is the Citral satellite imagery, and this is the tourism activities that also maybe the tourism activities is not a very broad like the water park that we see on the big cities, but this is a very potential. This is a very attractive for the villagers, for the local people in there, and the fee is very cheap too for the local people, which is $10,000. Or if we convert it to US dollar, maybe it's less than $1. So, and of course, there is this dam is also providing an alternative route to Malang and the Regency, which is to connecting the two cities. Because if we don't have the road to this dam, then to access the two cities, we have to a very long trip. And in the future, there is many potential to do, because there is a plan for the new hydroelectricity generator, which is two, of course, and will be added to produce 100 megawatt electricity to helping the electricity demand in Java and Bali. So this is maybe a short conclusion to wrap up my presentation. Tourism development in dam infrastructure is, tourism development in dam infrastructure is utilized as alternative financial source for operational and advanced development for the infrastructure. And with the right approach, tourism development can also help increasing local economy by providing work and market. And Karangates Dam, for my case studies, is still have potential to be better tourism site with its natural surrounding and huge body. Maybe that's all what I can present in this opportunity. Thank you very much for the attention.
Thank you very much for Mr. Teddy for your very comprehensive presentation. And now we move to the last presenters. The last presenters is Miss Kopal Duta from Deakin University. Miss Kopal Duta, the time is yours.
Hi, am I audible?
Yes.
All right. So my presentation is actually about the people. So I'm trying to bring the people back into the conversation. And as Baz said, the stakeholders are very important. And throughout the presentations, I've seen people come in and out of the whole conversation of urban water management. And this presentation is drawn from my PhD work, which actually looked at the social and the material elements of water. You're very familiar with the material elements of water, which is it lends to gravity, it lends to pressure, it lends to contaminants, it lends to geology and so on. But what I'm trying to do here is try to understand how it lends to the social dimensions and why is it important to ask. So whenever you're trying to solve an urban water supply issue, what we technically look at is the technical approach and the managerial approach, where we try to identify where are the bottlenecks, where are the leakages, where is the infrastructure rotting, and we choose options that suits us, whether it is public-private partnerships or government undertaking huge infrastructure remodeling and so on. And managerial solutions are basically looking at solutions that can be scaled up. So you do a pilot and then you can scale up for the whole country. I mean, that's the ideal strategy, right? But it still does not solve the problem. And the question is why. The answer to it is in the community, in the people. That is, when you are doing such large scale planning, you do not, more often than not, and as Bo said, a developer may or may not actually lend to a sensitive, water sensitive urban designing, and people are almost left out. So this is what my research interest, I think it peaked in water, and the current current chief minister of Delhi was the person who was responsible for bringing water back into the discourse of not only Delhi's politics, but country's politics. And today everybody is talking about water as a right. What is also important to note is that in the context of Delhi, water is treated as a public good, and therefore privatization is an anathema. Privatization is something that is frowned upon and not looked at as a good solution, although there have been stealth or covert privatizations of water supply measures in 3 different parts of Delhi recently. One was my study area. I am an urban political ecologist, so that's pretty much my lens, where I've looked at what the issue of water scarcity, and I have positioned that as a constructed, a concept. So water shortages are real, yes, but water scarcity more often than not is created. Now, urban water, before I move to what my questions and location was, water is a state subject, which means that the federal government does not really have a say in day-to-day operationalizing of the water issues. It is pretty much decided by the state government. And in Delhi, water is managed by Delhi Jal Board, which is an autonomous body, and it is responsible for distributing water to the entire 10 districts of Delhi. And if you look at the map on the right hand side of my screen, it actually shows per capita availability of water. And Mehrauli, which is my field site for this case study, lies at the bottom south, and it gets only 29 liter per capita per day. If you just look at big figures for the entire Delhi, the Delhi Jal Board gets about 906 million gallon per day of water, out of which actually only 40%, I mean, official figures says that 40% is wasted, but according to the economic survey, more than 50% of water is wasted. So, residents get only 300 million gallon per day of water, and that explains the water scarcity and inequality in water. And however, there are certain privileges that are assigned to the New Delhi and the Delhi Cant. These are the areas where the high and mighty of Delhi live, and they get absolutely wonderful amount of water, as high as more than 400 million gallons per day. My field site is a very ancient site. It never had underground water, and which is what it makes it very interesting that I am not arguing that it had water and over a period of time, suddenly water disappeared. It never had water, but it had, civilization starting at 1000 AD, and it continues.
We have 1 minute left. Thank you.
Sure. So Mehrauli, if you look at Mehrauli, this is how it is divided into several wards, and each ward has a very unique character. So despite the fact that it is serviced by the Delhi Jal Board and each house should get the same amount of water, water is available only 4 hours per week, and not every ward gets the same amount of water. So that was very interesting for me. What I did was I did actually a mapping of the water provisions to understand what are the water issues of the different wards and what are the coping strategies. And what I actually found out was that speciality, state access to state machinery and local politics are the key elements that decide who will get water in Mehrauli, and not just the hydrology or the geographical position of the people. What key findings that I have is that water flows, it creates centers of power. So in typical studies, you'd find that possession of money, possession of clout are the some of the key factors that allow you to access water. In Mehrauli, you'll find out that it's not true. For example, the Ward 5 here, this particular Ward 5 has one of the wealthiest population of Mehrauli, but it is located in a place which does not have enough road to let the tankers come in. So the coping strategy of people around here is very different than that in Ward 2, where you have minority population that are covered by the government regulations. So each sector, each ward has very specific set of population, and these specific set of population create unique bottlenecks that cannot be understood completely from a very technical or technological perspective. If you really need to solve problems, you need to immerse yourself and understand what are the crippling issues. And really, it is time to scale down and go to the down level to understand and actually have decentralized ways of decision making about how much water does an individual need. Pretty much circling back to what Baz had at one point in time said, individual requirements of water of people. So that's my presentation. Thank you so much for this opportunity.
Okay, thank you very much for Ms. Kopal. And also, thank you very much for all presenters for delivering a presentation in very comprehensive and very interesting way. We now move to the next session, which feedback and discussion. In this session, we have Professor Baskaran and also Dr. Sri Mariati. We have around 15 to 20 minutes for feedbacks and a discussion regarding the students' presentation for our today's discussion for our today's session. For the first, we have Professor Baskaran for give such feedback. Please welcome Professor Baskaran.
Thank you. Thank you for those who presented, and it's unfortunate we had to cut short the time to 5 minutes instead of a bit longer time as well. And I think one of the things we learned out of this is quite a lot of different dimensions of activities to bring together in terms of integrated water management, urban planning in an urban situation as well. I think the first presenter talked about his work on developing a framework in Indonesia for integrated water management. It's a huge task and a huge challenge, and looking forward to some of the outcome. And very often what we could do is looking at a particular area or a region and then develop for that and then try to expand that to the entire country, because when you started the entire country, it's so big and so challenging. It'll be good to look at much more focus on that. The other one is also, and TPAC one is more on the treatment technology side, and the treatment technology, it's ever developing, not only for removing certain aspect of it and some of the natural system. We're looking at treating some of the quality of the water coming through urban runoff and so forth as well. So how do we make the treatment system much more effective, much more cost, less energy usage and so forth as well. And the third presentation is about the dam infrastructure, and also is very cleverly linked to the tourism aspect of it. And it's a beautiful part of the country in between two big reservoirs, and creating a tourism attractiveness in that part will probably give enough resources to maintain those infrastructure as well. So that's a very clever way of looking at how do we support and fund these sort of dam infrastructures as well. And the last one is Copper's presentation. Is I think that's one of the missing elements of water management, because I call it, this is a hard stuff, a difficult question, challenging question. Because of that, nobody wants to talk about it. So if you want to make it happen, this is what I mentioned in Victoria in my presentation. We established these forums. These forums allow these sort of discussions to happen at a very local level and develop through that as well. The water management, we have all the planning knowledge, we have all the technology knowledge and so forth as well. What is missing is we don't have the good understandings of the social fabric of the area, as well as how do we influence the political system. And we are, as scientists and planners and engineers, we are not good at engaging with politicians, and because the politician never wants to listen to us. But it's an important aspect. If you want to make a change, we need to engage right at the social level, as well as all the way to the political system as well. Otherwise, there will be some roadblocks, and all the effort we put in cannot be implemented. And also the importance of the social aspect, because that's where the customer we are trying to serve. And if you don't understand what the needs are, what the challenges are, and very often in our planning and engineering system, we assume what they want rather than we ask them what they want. I think it's an important aspect in integrated water management. Thank you.
Thank you very much for your feedback, Professor Baskaran. And now we move to the Ibu Dr. Sri Mariati from Bandung Institute of Technology that will give feedback for our students. Please welcome Dr. Sri Mariati.
Thank you, Tami. So yes, this is very interesting discussion because the four presenter have their own approach to urban water management. The first presenter, Asri Samsu, put on more intention or institution arrangement, and I think. There is one thing that maybe you need to explore further, and this is very interesting. It's about informal institution, because in a country like Indonesia, it's not only formal institution. You're right. That also we have informal institution in infrastructure provision. Such as community arrangement, community institution. And so on. And the third speaker, Deepak, it's also very interesting. You have a view on the technical aspect on urban water management. And I think this is also very important because we face the problem of water quality, especially in, as Bu Roro presentation, this is the problem in our country in Indonesia. And the third presenter, Teddy, also have a view on a financial aspect of urban water management, how to finance the dam that also need operation fee or operation cost to be sustained to do the function. And the last but not least, from Kopal, it's very interesting because you have a view on the social and political aspect, and this is also is very important in like a country such as Indonesia, because everything, sometimes this is the key point maybe Professor Baskaran, the social and political aspect. Also in my presentation I mentioned that the degree of implementation of let's say green infrastructure and green initiative is depend on also on the leader of the region or the city, and I think this is also have a relationship on the how we create the sustainable urban water management. Yes, that's all from me, Tami. Thank you very much.
Yes, thank you very much, Ibu Sri, for your complete feedback. We arrive in the end of our session. Maybe we wait other to conclude our discussion based on the some of the question. Ibu Sri, could I read the question or no?
Yes, you have question or?
The question for the conclude the presentation.
Yes, maybe we can do that in this room together with other group.
Okay, Bu Sri. Okay, thank you.
So we still wait for the group. And here, group 2 has been here. Yes, yeah, maybe while waiting, Tami, we can you can ask the question.
Okay. For the participant, maybe have a question for about the presentation, about our discussion in this session.
Can I have a question to Kopal?
Sure.
Sure. Yes.
Yeah, like
That is yours.
how out of your your PhD research, what was the outcome? Like how strong are these political influences in taking a decision? Because as scientists or as other stakeholders, you will go with a a collaborative approach to them, but at the end of the day, they are the main key decision makers. So how is it there? What is your perspective in terms of
It's
that?
very interesting, Deepak. The situation, political situation is very interesting in Delhi compared to Mumbai. If you read some of the seminal works of people who do it in Mumbai. So in Mumbai, it is maintained by the municipal corporation, and therefore the political clout is very strong. Whereas in Delhi, it is Delhi Jal Board. So as Nikhil Anand would say, the public, the hydraulic public, is not very strong. And in my work, I was very surprised to find out that you do not pinpoint to a single factor, in particular in different wards. So Mehrauli is divided into 9 different wards. In some wards, the political presence is very strong, especially in the wards where there is minority population. So when I say minority, I mean minority as per the census, and it has no other connotation. So where there is Christian population, where there is Muslim population, where there are immigrants from Nigeria and other parts, Congress has a very strong hold, whereas BJP has very strong holds in the sectors where we have business community. So it is kind of very dissipated and diverse. And also, I did a household survey in one of the blogs to understand, as Bosri had pointed out, that for the green infrastructure, wealth is important. So my own understanding was that wealth will be an important factor in identifying coping strategies or access to water. And I was very surprised to find out in that particular ward, I did 25% of the population was surveyed by me, of the entire 100 household. And I found out that the class does not have a direct correlation to water supply. One of the reasons was because it was supplied by the Jal Board and by the state, and it's a proper planned sort of a setup. However, coping strategies are definitely influenced by class, but even then it also depends on where you are situated. For example, wealthy class is situated in Ward 5, but they cannot access tanker even though they have money, because the tanker cannot reach them. So they have to channelize other ways of political pressures, extra illegal measures. So these are very dissipated and very diverse problems and very diverse solutions.
Very interesting to see different perspectives and the factors which govern them. We never know this is the main key factor.
Totally. And in fact, so this is the area which is also being privatized now. So it is under the PPP. It has been given to a private company. However, it ran into all kinds of corruption trouble. So things never took off. But when I went and interviewed them, they told me that they are only responsible for water supply. Water is received from the Delhi Jal Board. So if there is no water at their end, there is no accountability of this private entity to the people, because they say that we do not produce water. We are here only to provide you the delivery. We are just taking care of the piped infrastructure, and that's about it. There is nothing else. And even so, it's not a solution, because the tail ends that are created in your language, if you understand, it is created by people hopping on to illegal mining of water because they have no other solution.
Thank you.
Okay, thank you very much, Ms. Kopal and Mr. Dupak, for your such as information for our discussion. And now we are still waiting for other participants from other breakout rooms.
Are we waiting for them or we lost them?
They're still in progress to join the main room. Yeah, but while waiting, it's a very interesting, Kopal, for your presentation. So now it's the situation after the the private enter the region, it's better or still?
No, as I said, Bosri, actually, this is more of an experiment. So they were trying to make sure that these particular areas have 24 hours of water supply. And when I spoke to people who are responsible for the water supply, they said, look, we get treated water from the Delhi Jal Board. If the Delhi Jal Board, supplies us adequate amount of water, we can provide these citizens. Otherwise, we are just here to do problem solving, and we can't really help much. And as I had shown in my earlier slides, that Delhi gets about 906 million gallon per day, which is only 74% of the required at the rate of 224 million liter per capita per day. So we already get less amount of water, and on top of it, more than 40% is wasted. So you already have very little water, and out of it, there is inequity. So certain sections, certain districts of Delhi, because they are, the residences of high and mighty, they have to have 24 hours of water supply. The other residents receive even lesser quantity of water. And these private entities can only take care of the supply infrastructure side of it. They do not have basically any rights over the treated water. So the situation isn't really much changed, and that is one of the reasons why there was so much of opposition to this whole privatization. In fact, our current chief minister was one of the flag bearers for anti-privatization in the early 2000s, when the World Bank came and said Delhi water has to be privatized to make it more efficient. So the whole efficiency argument doesn't seem to work here, in at least not in the my field site.
Yeah, I think this is a big area of the social and political aspects of urban water management. And how Rukmi had a similar challenges in Bekasi region as well, when we are trying to find water management issues as well. I think that's a bigger topic for another seminar, in my view, the social and political aspects of water management. And it'd be good to compare some of the practices and challenges in other countries as well. So
yes, I think all of the group has already here in the main room. Yeah, please.
Yep, they're back.
Yovita or Bunini?
Yeah, we hear, Bu. We have very heated discussion in room 3, along with Lloyd. Everyone's smiling. I think they managed to resolve all the dispute.
Yeah, so the next it's with Bunini or Yovita. So
Yeah, Yovita, return it to the master of ceremony of today, Yovita.
You're on mute, Yovita.
I'm sorry. Thank you, Bunini. And now we are in the end of this joint seminar. Busri, you have something to say for closing this joint seminar?
yes, I think it's I would like to thank all of the participants and also the speakers here, the teacher here, Professor Baskaran, Professor Lloyd, and also Professor Bau, Buroro, and also the moderator Bunini, Pak Heru also, and also all of the participants. I think it's very interesting discussion since the beginning, and also in the student presentation. And Professor Bas has also come to the idea to continue to make another webinar, because it is very interesting, especially if we talk about the social and political aspect in urban water management, and also maybe the institution. Yes, I will give it back to Yovita.
Thank you, Ibu Sri. Bunini, you have something.
I think it will be very nice if we hear more from Professor Baskaran to close the session.
Thank you all, and I think it's first of all, thank you for all of the participants. It's much more than the time what we expected. But the discussion was very interesting, and also we explored various aspects of urban water management, and there are some of the areas we touched upon it much more deeper. We need to go into, I think it's a broader discussion point. I look forward to our continued engagement with ITB and Deakin University in engaging in discussion with the urban water management. It'll be interesting to see whether we can do. We also have a similar arrangement with the Australia-India Water Centre, which includes several universities in Australia and several institutions in India. It might be something we could work together between Deakin and ITB to look at much more urban and regional water management side, and where we bring the other participants such as Bogor Agriculture University, which is deal quite a lot with the environment and the agriculture side, and also other departments in the ITB as well. I know your Faculty of Civil and Environmental Engineering do quite a lot of work in the water management side. So there's quite a common interest between both our institution, and hope we continue our discussion in all aspects of urban water management. And this is the beginning. And thank you for Ibusri to organize this one. And hopefully we'll bring other PhD students to engage in similar type of discussion as well. Looking forward to it.
Thank you, Professor Baskaran. Associate Professor Chua and Associate Professor Biubeza or Mrs. Kusamorokni, you have something to say in this closing session?
I'll just keep my comments short, and just want to reiterate that I think water management is a massive topic. In the breakout room, I said, that what we have in Australia is really something that is an outlier, meaning to say most of the world, a majority of the world live in a water stress condition, and that's why I say that it's a massive issue. So I think this is an important topic and certainly something that we need to continue to discuss. Okay, thank you.
Thank you, Professor Lachua. And anybody else? Okay, that's all for today's joint seminar. Thank you for all the participants, all the speakers, all the presenters for joining today's seminar. Hopefully the presentation and the lecture will be beneficial for everybody. Thank you and see you again.
Thank you.
Okay, thank you everyone. Thank you very much. Thank you.
Bye.
Thank you.
Thank
You may
you.
leave the
We'll
room.
see you next time in the next webinar, Bu Sri.
Yes, we will arrange.
Thank you.
Thank you.
Ibu Sri boleh dimatiin tidak Bu live di YouTube-nya? Tadi pesan